All right, let's dive right in. Today, we are going to peel back the layers of the C++ programming language and look at its absolute core. We're talking about the fundamental building blocks, the very atoms of code, which are known as C++ tokens. So, have you ever just stared at a block of code and it looks like this complex, maybe even intimidating wall of text? Well, what if I told you it's actually way simpler than it looks? What really is a computer program when you get right down to it? At its heart, it's a language. Seriously, just like English or any other language, it's just made up of words, symbols, and, yep, even punctuation. The moment you start seeing it that way and you learn to spot the individual parts, the whole thing just clicks into place. This is the first big secret to getting comfortable with code. And in C++, these individual parts, these words and symbols, they have a special name: tokens. A token is the smallest possible piece of a program. You literally can't break it down any further. Think of them as the individual Lego bricks that the C++ compiler picks up one by one to understand what you're trying to say. So here's our game plan. We're going to walk through the 5 main types of C++ tokens. We'll check out C++'s reserved words, the names that you get to create, those fixed values you use all the time, and the symbols that make things happen and give your code its structure. Trust me, by the end of this, you're going to see code in a whole new light. Okay, let's kick things off with our first category: keywords. The best way to think about these is that they're the special, unchangeable grammar words of the C++ language. They're already reserved for a very specific job. So a keyword is basically a word that C++ has called dibs on. It has a special built-in meaning that only the compiler understands. You know, words like int, for, if, or class. You can't just decide to use them as a variable name, because the language itself relies on them. They're part of its core vocabulary. All right, moving on to our second type of token. And this is where you, the programmer, get to be creative. We're talking about identifiers. These are just the names you invent for all the different things inside your program. Yup, identifiers are simply the names you give to stuff. You create a variable to keep track of a player's score. You might name it player score. You write a function to add up a total. You could call it calculate total. These names are all you. They're your creation. So let's just pause here for a second because this is a super common point of confusion for beginners. Let's make it crystal clear. Keywords have a fixed meaning baked into the C++ language itself. Identifiers, on the other hand, are the custom names you come up with. One is set in stone, the other is totally flexible. Our third token type is something called literals, or as you might also hear them called, constants. Now, if keywords are the grammar and identifiers are the names you create, then literals are the actual, specific, unchanging pieces of data in your code. A literal is just any piece of data where the value is fixed. It's not going to change when the program is running. For instance, the number 100, it's always 100. The text, hello, is always going to be hello. These are the concrete facts your program works with, whether they're numbers, single characters, strings of text, or even just a simple true or false. Next up, let's meet the action heroes of our language: operators. These are the symbols that actually do stuff. They run the calculations, they make comparisons, they perform all the operations. You could say they're the verbs of C++. And you already know a ton of these. They're used for all kinds of math and logic. I mean, think about the classic math operators like plus and minus, or relational ones like less than, greater than, and of course the one you'll use all the time, the assignment operator, that simple equals sign. They all take some values and perform an action on them. And finally, we've got the symbols that bring order to the chaos. Our fifth and final token type is punctuators. And yeah, the name pretty much gives it away. They act exactly like the punctuation you'd use in a regular sentence. These symbols are all about organizing the code. That semicolon, it's like a period at the end of a sentence. It tells the compiler, okay, this instruction is done. Brackets are for grouping things together. Commas separate items in a list, and that double slash, that creates a comment for us humans. Without these guys, our code would just be one long, unreadable mess. Okay, so we've met all 5 types of tokens. Now for the really cool part. Let's take one single, simple line of C++ code and break it down piece by piece, using everything we've just learned. First, let's look at int. Does that have a special built-in meaning for the compiler? You bet it does. It's telling the computer that we want to create an integer,
a whole number. That makes int a keyword.
Okay, what's next? Score. Is this a name that we, the programmer, made up to label something? Yep. We decided to name our variable score. So score is our identifier.
Now, how about that equals sign right in the middle? Is it doing something? Is it performing an action? For sure. It's taking the value on the right and assigning it to the variable on the left. That makes our equals symbol an operator. And the number 100? Is this a fixed, unchanging piece of data? Of course it is. The number 100 is always going to be 100. That makes it a classic literal.
And last but not least, that little symbol at the very end, the semicolon. Is it giving our code some grammatical structure? Yes, it's the period on our sentence. It marks the end of the statement. That makes our semicolon a punctuator. And look at that, one simple line, 5 different tokens, all playing their part perfectly. So the next time you look at a piece of C++ code, don't see some impossible puzzle. See it for what it is, a language. Look for the keywords, the names, the fixed values, the action symbols, and the punctuation. Because now you have the key to deconstruct and really understand any line of code that comes your way. The only question left is, what are you going to build?